Okay. Okay, so welcome again, everybody. So this session will be devoted to sort of what we call the horizontal themes, which, if you remember the structure, the strategic research agenda structure of the flagship, there were these 4 pillars, plus basic research at the bottom, plus some horizontal lines. So here we would like to speak about the horizontal line and may discuss about their purpose and maybe discuss about a little bit of restructuring, because some of the horizontal line were basically not treated as such, and as we all know, the basic research was strongly oversubscribed. So maybe we can do better. So these lines are indicated here. And then purpose of this thing would be maybe to propose a way to restructure, that is to put all that together in some sense under the name of scientific and technological resources. So people here are Tony Yassin, who will coordinate with me, and we have 4 panelists which sort of represent each, so including Tony, represent each of these 5 lines, software, theory, engineering, and control. And we will think again about that. Okay, so why introducing these scientific and technological resources? Actually, I'm coordinating a mini flagship. No, maybe not yet. Just this is a little reminder of what they are in the current SRA, which was designed by the high-level scientific report. So we have basic research, it's written, horizontal fully cross-cutting domain, delivering concept, tools, components. Then we have engineering and control, driving the transition from concept to experiments, devices suitable for applications. And we have software and theory, including control certification to understand and profit from the quantum advantage. So this is the current state of the art. This is how they were defined by the high-level steering committee. So why using the scientific and technological resources? So as I said, I'm coordinating a mini flagship, but it's a pretty big flagship with 700 people in the Paris area. And we introduce this idea of scientific and technological resources, and we find it very convenient. So why is it convenient? So it's a very generic, let's say, entrance door to what is needed to achieve the goal of the flagship, but which does not really fit yet in one of the pillars or main applications. It's very easy to explain to funding agencies that we need resources, we need new ideas, new technologies, new manufacturing abilities, so this fits in there. This provides maximum flexibility because, well, basically you can structure the thing depending on the current need, and this can evolve with time. This may be used on the scientific side, especially if you have completely new ideas which don't fit in a pillar, let's say quantum biology, or maybe in the future an interesting things. It can enter there as a sort of a new idea on the theoretical side. On the technological side, there are many issues with clean rooms and things like that. So this is also easier to manage maybe at the general flagship level. And I insist also, this is sort of accompanying things, but it is not training, outreach, innovation, which are in other parts of the strategic research agenda. Okay, so what do we learn from this morning? So what are the real cross-cutting areas? What do we need enabling? What are the added value with respect to different things? How do we proceed? How to ensure the presence of this cutting theme in the future of the flagship? So I will ask a short contribution to each of the panelists. So let's start with Tony about, so they will sort of summarize what came out from this morning session in a few sentences, and then we will ask you about what you think about it. So Tony, about basic science.
Okay, so I don't think that much was said during the morning session. I mean, there was a very provocative comment by Nicolas Gisin, but I think Nicolas is not here. Okay. Okay, yes. Okay, so Nicolas was saying that we should perhaps remove basic science from the flagship. Okay, so it's a pity that he's not here to elaborate more on that, but I think it's something. And but I would say I just want to say something about what Philippe also presented. I mean, he presented an option about how to structure this horizontal effort. Okay, so we are here to discuss about this, and one possibility is this resource approach horizontal that was followed in Paris. And I think we all agree that the role of basic science, we are not happy with how basic science went in the previous call. And I think one of the problems is that for the horizontal pillars, you needed the participation of an industry, and whenever you didn't have an industry, you were basic science. And then everyone was submitting something to basic science without an industry. So I think we should fix that, because otherwise we will, everything that we come up will be oversubscribed, whatever it happens. Okay, so this is also something that I would like to raise here for discussion.
So Sabrina will speak about
theory. Yes, and what I will say is strongly related to basic science as well, because obviously you can have theory that is applicative and it is related to a specific platform or a specific industrial problem, but you also have theory that is truly transversal and covers all the pillars, and this type of theory is within basic science, and we believe it is not represented. A huge part of the community is doing this theory or is doing basic science and does not feel represented. So the question is, again, whether or not we need to have this within the flagship. And going back to Nicolas Gisen's provocative question, of course, one option is really to say, okay, basic science is outside the flagship, but there is a risk, because we should remember that in the next framework program, most likely we will not have any FET, so there will be no funding instrument for basic science, and therefore this part of the community will be somehow without funding instruments. And so I think it's important to understand where we want to go. And obviously, if we want to have basic science and theory within the flagship, then the criteria against which the projects of basic science are judged cannot be the same as those that are used for the pillars, because clearly in this way they will never be have any chance to be funded, obviously. So this is one of the main points, I think, to discuss.
Then John Morton is here.
So I'm going to speak on behalf of engineering, which is a difficult topic, because in many ways, if you speak to many people, engineering is almost everything of what this should be about in terms of developing technologies, taking stuff out of a physics lab into end use. And so what we've tried to do is dig into the engineering a bit more and think about what are some of the key resources which are likely to play an important role within each of the different applications areas, and that in fact should be, that it's difficult to imagine an applications area and a pillar without such resources. And so amongst that list includes fabrication and materials. That's something that came up in some of the sessions today, talking about access to advanced fabrication facilities that go beyond what individual university level groups have been using so far, but harnessing some of the really world-class microelectronic centers and facilities that we have within Europe that I think really put us at the forefront of the world, and whether that can be whether that can apply to other types of hardware platform and materials as well. Related to that, there was a comment about mirror coatings currently being provided by one person in Boulder for the entire community. Thinking about these kind of strategic questions, being aware of them, so that the sort of European effort is protected. So the second one was in subsystems and components, and that also came up a discussion of, about these individual components, the lasers, the control systems, the FPGAs that are going to be assembled together with the quantum component to make a complete system. So that's a topic around the subsystems and the systems engineering that bring those all together. That's another topic that we would imagine existing across all of the different applications areas. Then moving a bit more into sort of theoretical in the domain areas around verification and benchmarking as a common theme which must exist across proving an application's performance. Particularly interesting questions around quantum simulation, where you don't already know the answer may be harder to verify, but clearly also in other areas like communication. And I think that those cover some of the sort of main topics and I think being a bit more detailed than just engineering will help tease out exactly what those key requirements will be.
Thank you, John. So, Stephen Glaser for control.
Okay, in terms of control, this morning I think it was clear there were actually several levels of control people consider. There was a lot of discussion about like electronics control, but there is a huge knowledge and huge expertise in Europe also about quantum control, and that's basically the community I'm representing. I mean, the other topics are what is the time optimal way to do a certain quantum operation, how to best prepare a certain state, how to have optimal readout, to have robust operations in that kind of applications, to closed loop control or open loop control. So there's a huge community and huge know-how, and so it's important that the different projects that are funded and will be funded in the future actually also be able to tap that knowledge and have this connection. So for example, from my point of view, since we only know now what are the funded projects, I have, for example, no overview how much control expertise is in each of these pillars, and something that was discussed this morning also was how to facilitate that people in certain funded areas actually get contact and have interactions with experts in different areas of the cross-cutting areas, including of control. So I think that's important to facilitate that. Actually, there are other funding mechanisms like national funding, and also there's there are several control-related European Marie Curie actions, innovative training networks, and I think so. There's a lot of contact points, and I think it's important to for the projects to actually reach out to the control community, and we will reach out also to these projects to facilitate that interaction.
Thank you. So, Harry Bowman for software.
Yes, so I'm going to say something about the software that came up in the sessions I went to. That was computing and simulation. And it became clear that software actually is a very broad area. It ranges from applying software to low-level hardware, if I may say so, up to high-level applications and algorithms that connects up with industry and like big software companies like, for example, SAP. And what's clear that if you want to have a healthy quantum computing flagship in a quantum computing industry, you need to have three components there. That is the hardware, the software in this very broad range from low level to applications, and you need the users in the industry in this case. And apparently it is missing at the moment the industry and the users, as well as this high-level application software currently is missing in the flagship. And this became apparent both in the computing and in the simulations sessions. And moreover, what is important is that the development of these applications, of these quantum applications in this quantum software area, they have to be done independent of the hardware development. So these things have to be decoupled, as history teaches us from the classical computing. That doesn't mean that it is completely decoupled. It is decoupled on the low end of the software stack, but the high end has to be able to develop independently, and we have to think about how to incorporate this in the current flagship.
Thank you, Harry. So, well, you just heard small remarks, so we can start with questions. So, please.
Mikko Möttönen from Aalto University of Finland. I wanted to ask the first question because this is a general question for everybody, and I think it's a very hard one and tough one, and I hope that some of you guys can give some sensible answer, at least partly, to this question. We're talking about cross-cutting themes, and I think we agree that, okay, these themes that we're talking about, they should be cross-cutting. Now my question is that, are they really now in this flagship, as it's been implemented, are they cross-cutting? And if the answer is no, they're not yet, my question is that, what are the instruments to actually make them cross-cutting? What are your proposals to do that?
I want to say something.
I guess that maybe...
Oh, you can start.
Just one second. So, okay, the scope of this session is not that you ask questions to us. I think it's just more that you propose ideas about how to implement things. It's not also about discuss what happened in the past. It's more about what we want to do next. Maybe based on what happened in the past. Yeah, okay, but I think it's. I think we are happy to get questions, but it's not the purpose. It's more like I think this happened, and I believe this should happen. Okay, we can provide our information. Okay, but it's not. It's not that we facing you, getting questions from you, and providing answers. It's more a discussion. Okay, but.
I don't mind answering Mikko's question, or indeed anyone's question, within reason. So, I completely agree that the way I view these are essential scientific and technical resources, that each of these applications should have activities within fabrication. They must be able to build things, within verification, within basic science, within subsystems, because they're all essential ingredients about producing an end product. So they're essential resources that will exist across the different applications. That doesn't necessarily mean that it is a single cross-cutting activity. It doesn't mean that the same fabrication tools or facilities that are used to make quantum computers are used to make the components of communication systems or sensors, because evidently, in my view, that they're not. 90% of these activities are not going to cross-cut, and they shouldn't be forced to for an arbitrary reason. What I think what is important is that we recognize that they are essential to developing practical technologies, and that they should feature in some way within each of these different pillars or applications areas.
Yeah, just one more word. Maybe, these cross-cutting things were not in the call, actually. They were implicitly in the call. So it's one more reason to, as John just said, to remove this thing, which may be a little bit misleading, and rather to think about scientific and technological resources, which are generic things which are required to achieve the goals of the flagship, but which are sort of new or offset. So it's a way to manage an entrance door to the flagship, let's say, with the idea that everything should eventually fit in a pillar. This is what we do in our mini flagship in Paris, and it works quite well, actually. It's a transitory stage in some sense. The goal is not to stay there, but then ultimately it should be used for the real purpose of the flagship. No, but forget about cross-cutting. Let's say, as John said, look to the future. No, but no, it's resources. Look at it as resources. What you don't have and what you don't need. Just as John said, it may be theory, it may be new theory, it may be new fabrication devices, it may be anything. And in practice, it does work.
So Andreas Wallraff from ETH Zurich. So I think one thing that really many of the quantum computing and quantum simulation applications have in common that are based on solid-state systems is they require micro and nano fabrication at various levels. And at the moment, many labs do some of that in their own facilities, but it will require integration while maintaining coherence properties. So fabrication technology and material science will come together in a way that is very, very difficult to get to a final product. Yeah? And I do think that even the advanced university clean rooms will probably not be able to address that at the level that we really need in the end. So I think this will be, many colleagues would probably agree that this will be an essential step towards reaching the final goals there of building quantum processors. And the question is how to go about it. Yeah? And certainly there are facilities like IMEC and LETI in Europe, but they make conventional electronics, yeah? and they need to adapt their processes to be viable for quantum processors. And it's not just an engineering task, it's a combined science and engineering task. And so I think many could probably benefit if there was an activity there that was steered in the right way. I think it's probably not automatically you spend a lot of resources or so you give 100 million euros to IMEC and good quantum processors will fall out. Yeah, it's not just an engineering challenge at this stage. Yeah, it's the right combination of doing the basic science, doing the characterizations, but also working on the materials together with the integration of these circuits, which I think is very important. and that needs more support. It's not supported within the current flagship programs.
It may fit within this idea. That is, again, what we are doing. But you see, there are many efforts to make joint clean rooms in Europe, for instance. There are people here who are working on that. So how to connect them is certainly a complicated problem, but it can be dealt with within such a structure, especially if it is interesting for several projects. Yes?
Winfried Hensinger, University of Sussex. I'd like to maybe make some comments which were already made in quantum computing and quantum simulation session, and actually maybe relating back to what Harry said before. So I think what is really missing is a very, very strong focus on use cases. Now, it's quite obvious that the funding within the flagship is far too little to really develop a large-scale quantum computer or a large-scale quantum simulator. The only way we can achieve this goal is with significant industry uptake. And industry won't provide this uptake unless we have really good use cases, software cases. And so what I would propose is, and this will then also settle things like what platform to go and provide sufficient funding to develop sufficiently many platforms. But all of this only is going to happen if we have a stream within, and this perfectly fits within basic science cross-cutting themes, combining quantum simulation, quantum computing, and having a stream where we look for industrial use cases that provide economic prosperity. We can't look into quantum magnetism or things which may be interesting for many of the academic people in this room. There need to be use cases where we can make a very, very clear case that this provides a financial incentive for companies to invest in excess of tens or hundreds of millions of pounds, because that is required.
I agree with that, but don't you think that the use case should be in the application areas, in the pillars?
No, well, there's this misconception that people think that somehow we already have all the use cases, and people like Harry and others just somehow in the evenings work for free in order to make these use cases. This is tremendously a lot of work. We work with a big financial company, and we've been working with them for 2 years, trying to even understand the difficulty of classical, of the conventional algorithms and how they get to the limits. This is a lot of work, and that needs to be funded work, and it can't be just put somehow, for me, like as an experimentalist trying to build a quantum computer, I can't just quickly put that case, someone application and this really needs a lot of
If it is really connecting with the companies, it may be also connected to the innovation working group, which is not here we are mostly concentrating on research and development, let's say R&D, but is Thierry here? Thierry de Buchert is in charge of the innovation working group, and I think this kind of thing may be also considered in this framework.
I just think the research needs to go towards usage cases. That's what I'm trying to say. No, innovation is different. I think you misunderstand what I'm saying, because I'm not saying that we somehow should work with companies once we have a product close enough to market. I'm saying something entirely different. I'm saying that right now we need to direct a lot of resources into developing usage cases that are so convincing to big companies that they're actually willing to put on tens or hundreds of million pounds on the table. We can't just say this is kind of has applications in quantum chemistry.
Okay, so, thank you. So, other comments?
Can I say something? Or?
Sorry, who is?
Can I say? I agree completely with what Vinny said.
Yes. Yes. Sorry. Yeah. Was
well done.
Other comments? Yes, maybe Eugene here, and then after down there.
It's a very quick statement. The latest issue of The Economist has an article about something which they call the post-Shor stage of quantum computing. And I would love, experts to read it and see whether there is any sense in it. Because they're talking about the new classical ways of encryption, which is kind of immune to the factoring and stuff like that.
Okay.
Victor Land from Eindhoven University of Technology. There's one more cross-cutting theme that I would suggest to add. By the way, I totally agree with what was said previously, but we already had the discussion. But it's also thinking about mission-oriented approach for the next framework program and much more cross-disciplinary approaches in the national funding schemes. There's societal engagement is just missing, right? So we're developing technology and innovation, but yeah, in the end it needs to land into society. So something should be added in our flagship that takes cover of how do we engage society with the quantum technologies.
But you mean outreach or training?
No,
or?
that's an old misconception. I think a similar misconception. I'm not just talking about writing a good paragraph that explains how important your research is. It's really engaging the society with the research that you're doing. It's a completely different concept. So my advice, you asked for advice, add a cross-cutting theme and funds for societal engagement for your quantum technology development.
Okay. Can you please elaborate? Because I don't understand what you... So what are the actions that you are supposed to do in this?
Well, will society simply accept the use of quantum technology in their quantum internet? Just something like that. Or if I will have a quantum secure smart home, is it accepted that I have a quantum card to enter my house or something like that? I mean, all these different ways. It has to do with business models, but it's also end user acceptance. And I think citizens are quite important, and citizen security is a central theme in Digital Europe also. So it's a citizen-centered approach for your quantum technologies.
But do you think it's a R&D issue, or it should be rather dealt with by the CSA, for instance?
It might not be a typical R&D issue for your average engineer or physicist in the room, but definitely I think these are R&D issues in many different departments in the universities being pursued. Okay. And the mission-oriented approach in the EU will require collaboration with many different disciplines.
Okay, thanks. There was somebody at the bottom, right at the bottom, close to the window.
Hi. I think one cross-cutting issue that's also relevant to use cases is just so we know, when we get to 50 qubits, what interesting problem can we do? How many qubits do we need to do high-temperature superconducting simulations? I think at the moment there's no widely known answer to this question, right?
Sure, our goal is to get one.
Specific chemical simulations that can be done at so-and-so qubits at so-and-so error rates. I don't think there's an answer. I think if we as a community come up with answers of we can do this when we get to so-and-so qubits, we can do that when we get to so-and-so qubits, this will be very concrete and specific in terms of commercial companies. They'll know when it becomes interesting. It doesn't depend whether it's transmons or optical or ions or whatnot, so it cuts across. And it's a relevant scientific question that, as far as I know, there is no concrete answer. And I think it's important that the community figure out how to answer that question. What can we do with so-and-so?
Sure, I agree, thank you. These are very difficult questions, and our job is to answer them, but not maybe right now. So there was a question here.
Oh, yeah, a suggestion. Jonas Bylander from Chalmers. We are going to develop firmware and standards within one of the quantum computing projects, and I think that would be useful also for example, for the semiconductor quantum computing projects that was announced yesterday. The call will come out, and for other projects within this flagship. So that would be a cross-cutting theme, that we can use the same standards and software in a new call.
Okay, thanks.
Great. So just to reply to that, that's exactly the kind of thing that we envisaged behind this verification and benchmarking theme. And just to pick up on the other points, so where there was a discussion within the SRA around having app development or user engagement as a cross-cutting theme, or not cross-cutting theme, old terminology, as a scientific, as a sort of key resource that should exist within these pillars. And I think the overwhelming message from the floor is that yes, it needs to be there. And particularly on this point about the ethical questions, I think this falls, at least within the UK, of what we call RR&I, responsible research and innovation. It's now a mandatory part of our quantum activity, and we have researchers in RR&I doing the engagement with the scientific community, the engineering community, and the end user community to tease up these issues. So that's an activity that could also fall within this kind of user engagement app development area, but I agree that it's something that needs to fit somehow within the overall program.
Yes, there was a question here, yes.
Yeah, Mikko again. Thanks, Andreas and Jonas, for these, detailed comments on the cross-cutting or the key things. Maybe my first comment was on the too general level that it is hard to understand. What I was trying to point out was that there are these key issues like fabrication that Andreas pointed out, firmware that Jonas pointed out. Then there's also a higher level software. There is classical electronics. There is cabling. These are kind of key technologies that we need to develop a lot to get a quantum computer. And now it's not optimal for these to be developed individually in the projects themselves, whereas the project could benefit from a wider sort of effort.
Mm-hmm. Yes,
So this was my point, that now, for example, the way projects are now started up it hasn't been prepared for that. And I think that now is the right
this is
point.
What I already said. It did not work well, and our purpose here is to get it to work better. Yes.
Yeah, exactly. So now is the point to really take this issue and solve it. Like the basic science projects, for example, they now seem very separate from the pillar projects that they are supposed to somehow support.
Mm-hmm. Okay, thanks. Other questions here? Yes. Okay. Yes.
Okay. Hello. Yeah. So just to go back to the R&I principles, and with danger of inflicting the discussion we're having on basic science, I think coming from two different families. So RI is the engagement of people in research. And I think it's a misconception that if we develop quantum technologies in vacuum, there is a very high risk that this is not going to be applauded by users at first. And so I think you can see from a lot of other technologies that have been developed that they confront a challenge in applying it to the benefit of citizens. So this morning I rode a taxi from one place to another, and the taxi driver told me, "What are you doing?" I said, "I came here," and he said, "Oh no, you're going to develop some technology that is going to take away not only my job." He was talking about the self-driving cars. And I think this is a good example of where the EU and the Commission and us researchers, we have a problem. So we develop technologies that we think are great, but people don't understand it. And I'm not talking about public announcements. I'm talking about developing these technologies and not doing it in vacuum. So a suggestion, there is the Science Within for Society program. There is the RRI instruments. There are a lot of stuff, but they're not connected. So we were told that the RRI are going to be written out of the Horizon Europe program. It's going to be called Open Science. If this is the case, could you then keep in mind that we would like some instruments still that does this, because this has not been successful in the past. And I think with quantum technologies, there is a new chance of getting this to succeed. And so that we're not developing a technology in vacuum, but we're engaging the people that we actually work for, all of us. Thank you.
Okay, yes, thank you for this. Again, I think it's maybe more in the domain of the CSA rather than the pillars themselves. But no, you don't agree again. Okay, well, okay, thank you anyway. Yes.
Hi. I'm Araceli Venegas-Gomez. I'm working at the University of Strathclyde in the UK. I'm trying to find the answer to the last question I'm seeing there. I think first we need to identify the competencies and expertise across Europe. Once we know which institute, which group has a very specific competence and expertise, then we should ensure the coordination and transparency across Europe, within all groups, within all the different disciplines. So it's something that is not easy, because we are talking about different countries and different institutions, and by experience it's not easy when we have different stakeholders involved. But this is something that we should really take into account, the coordination of different disciplines and competencies across Europe. Thank you.
Thank you. More questions here? Okay, so Tony will lead it. Okay, yes. Here first, and then we come back.
Yes, hello. I wanted to react to the comment that was before about acceptance of this research in quantum technologies. So I'm thinking also from my background in evolutionary game theory, medicine, psychology, and I think this is true because I think different people have different viewpoints that are also like maybe influenced by biology, and their different thinking might make them feel uncomfortable with certain products and technologies. So I think maybe kind of psychology, philosophy has to be also looked at to try to find out how will people react to certain things. So I think even maybe medicine, psychology, genetics would be important to look at to really get a result in that area. Okay, thank you.
Okay, thank you for this comment. Yes, Michel?
Yes, Michel Labachelerie from Euro Nanolab. Just want to add a comment to the sentence, what are the required fabrication facilities? In fact, the fabrication facilities already exist. That's clear. There's a lot of, at least, micro and nano fabrication facilities in Europe. The problem is that they are very fragmented, so it's very difficult to have a collective effect. So what would be very important for this quantum technology community is to be able to identify the main relevant questions for nanofabrication that are relevant for any kind of, for instance, qubits that are different, that are working with different technologies generally, and try to federate, in fact, the competencies that already exist in the nanofabrication community. These competencies are here. The question is to try to group them correctly to be able to tackle the problem. And the question now is, what are the problems? I think that it would be very worth trying to establish a meeting, a specific meeting on these questions, because we should start the work on the technologies, not at the end of the flagship when people know what they want to do, but at the beginning, when we know that we will have to have at our disposal some kind of technology.
Yes, just for a comment, Michel de la Bachelerie is already in charge of the French network of nanofabrication facilities, and he's setting up one new one at the European level. Is it correct? Yes. So I think it's quite important that we can connect with these structures. More questions? Yes, here. Okay, first, sorry.
So I guess I would back up the former point. I think I would extend it not just to nanofabrication though, but also to the fact that very often you've got combinations of specialist chips, and so this packaging and interfacing problem is a major problem for any of these technologies. And somehow there, maybe it's useful to have people from the different technology areas supported in the flagship, making sure that they're attending working groups of the other technology areas. I think there's crossover, for instance, between ions and integrated optics and things that could be useful.
Yes, I work on that and I agree. There was a comment here, yes? Sorry.
My name is Sadiq. I'm from Zurich Instruments, and I'd like to mention on a very cross-cutting action that we are actually working on. So as a young company, we're like a 60-people company. We're developing the electronics for superconducting systems in the Open Supercube project. And from our perspective, like, our goal is to develop this and also offer it to the semiconducting folks, and also, of course, to all the other products. Now, we do this as a normal participant of our project, and now you could argue, do we need a dedicated call where we could develop the electronics, like a dedicated program? And I'm not so sure. Actually, for Zurich Instruments, for us, that we strive to go across all that, it is absolutely fine to be a a full member of one consortium and then exploit that to all others.
No, sure, I fully agree with you, and it was already the case. Many little companies are already in existing programs. So this thing is for new things in some sense. So if you can already fit within a computing pillar with projects, this is perfectly fine. I think this is the final goal in some sense.
I think the alternative model to have a dedicated program is also viable. I just want to make a point that for us it works.
Sure, perfect, thanks.
Thank you.
There was a question here, yes?
Thanks. My name is Dieter Sutter. I'm from University of Dortmund, and I would like to try to steer the discussion in a slightly different direction. Most of the votes so far have been about, say, infrastructure and support actions like fabrication facilities and so on. But I think there is a more important theme that has not been covered so far, except with a few, like this standard setting. I mean, the problem that I see a bit with the structure of the flagship is this division into the 4 pillars. And that makes it difficult for some projects, which would be very much worthwhile in my opinion, because you have to decide to which pillar you want to belong. Let's give a very simple example, quantum image processing. I mean, is that image processing sounds like computation. However, this only makes sense, or it makes much more sense if you can combine it with communication, because you may want to encode the image somewhere, which actually would be quantum sensing, and then you want to communicate it to somebody else. I mean, we know that the internet is now mostly filled by images and movies, and then you want to process it, and quantum algorithms can have an enormous speed up on image processing. Now, if you want to do such a project, to which pillar do you have to belong? I don't know. And I think this cross-cutting could help a lot in that direction. For instance, by setting standards, as we heard before, and it would also have to try to reduce problems which we do if we decide for a specific hardware platform. Say, the quantum communication people, they decide on, I don't know, photonic qubits probably for communication, but the quantum computing people, they decide on superconducting qubits. And the quantum simulation people, they use ions. So if you have a project which involves all these different fields, how do you combine these different parts? And I think this would be something very important for these cross-cutting themes.
Okay, thank you.
If I can say something, I just want to connect it to what was mentioned before. I think if you have something that fits in a pillar, it's better. And I think what you do in France, as soon as you see an option of moving something that has been submitted to this horizontal structure.
This is the way we proceed in France. Yes, this is like an entrance door. But as I said before, the goal is not that people stay there. It's more than if there is any reason to put them in a pillar, we put them in a pillar by authority in some sense. And then if it doesn't fit for various possible reasons, then it can stay here at least as a, because in practice, you see, there are many reasons. For instance, nanofabrication, is a good reason. Also, there are some theory which is really transverse. There are issues like, I don't know, certifications or completely new subjects. It's what Tony just said. The ultimate goal is it goes to a pillar for, I think, clarification, both from a scientific point of view and from a, let's say, management or European style point of view. And this is a way to enter the flagship, for subjects which are not so clear, but which are clearly needed. I like the idea of key resources, actually. Maybe we may use it.
So also, I just want to raise a point now. So clearly, I think people, again, I come back to the basic science because I'm representing basic science. So I don't know if anyone has comments about how to incorporate basic science in this structure in a successful way, because it didn't happen in the previous call. I don't know if you have any comment about this. I don't know if you have something to say.
Okay. Oksana Mishina, TU Braunschweig. I think to combine what we have said yesterday and today, first of all, the success rate which we saw was 10%, which is a good observation. And worldwide, funding agencies agree that starting from 20% risk success rate, the healthy community starts to exist. So if it's below, it creates really a lot of friction. So I think we should work on increasing the success rate, which means increasing the money, right? But the way how to do it, as we saw this large spectrum of the basic proposals, and it was not clear for people who apply into which part to apply. Seems like we are not yet clear within ourselves what the basic science is. So it's presented in a very large scale. So addressing the suggestion which was already given, which is give new guidelines to what we decide, we as the community, maybe with a vote, I don't know how, what we decide to be on the side of a basic science or to be funded within this basic science call is something that we should address. I don't know if this is the meeting to address it, so shall we ask people to raise their hands or no, but this is something that is key. It was so unproportional first, and first of all, I think we do have some margin on the balancing where to apply. But second is the awareness of ourselves, new awareness of what the basic science is I think still to be clarified and to be really presented to us so that we know what we are expecting from ourselves, because there are different opinions.
No, I agree. So this is our purpose, but I would like to insist, it's just the start of a project.
Absolutely.
Today is the launch of the flagship, and this discussion it just started today. It will continue, and it will be taken over by all the governance of the flagship. It will continue in Grenoble. There is no immediate call, but we have to structure to answer your questions before we come to the future. And this discussion is starting today, and this is just to answer your question that we are working and discussing these points.
Very good. Very good.
Andreas?
I think maybe some of these questions relate to what Nicolas Gisin has maybe trying to say, even though I wasn't there when he said it. I think one of the worries that we have is that okay, basic science will not be funded, basic quantum science will not be funded anywhere else if it's not in the quantum flagship. Yeah? But whether that's the case or not, I don't know whether we have influence on...
He said it as a joke. He said it as a joke. The best way to fund basic science is to take it out of the flagship.
but I mean, okay. there is a question. If there was, I mean, Europe has 20 years of maybe even more than that successful research in quantum science, yeah, and it will stay as interesting as it was previously, and there will be a lot of basic science that is at the same level, but it's not. It's maybe not necessarily following one of the strategic goals of
Nicolas is not here. No.
I mean, I'm not addressing Nicola, but I wonder whether this worry comes from the fact that you feel that, okay, there will be no ERC grants in anything quantum anymore. There will be no other quantum research.
No.
But can I say something related to that?
I'm not sure whether there's any strategy.
Sabrina, we said something.
Can I say something? Of course there will be, I think that there will be, or at least we all believe there will be ERC. The question, however, is whether there will be calls that are across Europe, so for collaborative projects across Europe. If FET Open and FET in general disappears in the next framework program, and if what is left for basic science really is ERC is individual, it's not collaborative. So then there might be this issue to consider, okay? And so there might be the lack of really. The only thing left would be really the Quantera. and not all the countries are participating to Quantera, of course, as we know, and otherwise, well, of course, cross-sections are not the appropriate tools because they don't fund research. So with the disappearance of FET Open, it is a reasonable question, I think, to consider what will happen if basic science does not stay within the flagship. Okay.
Yeah, yes. No, but
but does this
Nicola
apply
is
to
a little
all
bit
basic
provocative,
science?
and so maybe yes, Eugene wants to comment on that.
Well, wait, just there was first here, and then you.
Yeah, no, but you want to comment on that or not? Just an immediate comment, yes, and then we go to.
Very quickly, just for the sake of detail, there is a Synergy ERC grant program, right, which funds the teams of 3, 4 people, but it's certainly more than an exception than the rule. It's very hard to get there.
Okay, thanks. Yes?
I guess on the cross-cutting team, something that might have some impact on what to choose there is what the funded and existing project, what do they identify as missing, what are they needing, and so I think that's probably also important in general for the overall quantum flagship. I mean, to really support, to really see what those projects needs. And they might also need some basic science. I mean, I don't know what those projects will say, but I think that's a way into also to sort of steer or influence the choices.
Okay, yes?
So just to comment on the basic science idea and how to incorporate that, I think one interesting suggestion, it's been named as a key resource, is for this to exist as a key resource, basic science to exist as a key resource within each application pillar. And then, and in fact, that's a reflection of what's happened to some extent, in that each of the successful basic science projects to some extent address one of these applications, but also by having it sit by itself, it's a target for, to ask what it's good for, but when it sits within an applications area, and as you say, that there can be a clear message on how that feeds the future of future applications, then it can be protected and be incorporated within the flagship and be easier to justify.
Okay, so we are basically over. Maybe if there is a last very urgent question. Okay, so down there.
I just want to reassure you that FET Open should not be stopping here.
Speak closer to the microphone.
Very close. Right. So just to reassure you, and I need your support. We have been all somehow for years now, actually this year we are celebrating the 30th anniversary of Future and Emerging Technologies. So it's a good anniversary to start a quantum flagship. So, and really we are all very proud about that. Nevertheless, there is still an issue about what would be the future of FET. I hear some of you being really concerned about it, and I can tell you I'm also concerned. I'm Thomas Cordes, the director responsible for FET in the European Commission. So we have been making a lot of work with my colleagues from DG Research to safeguard the future of FET, both FET Open and FET Proactives. About flagships, you heard all the discussion yesterday, so I'm pretty much sure that we will manage to continue it under excellent conditions. But on FET, and in particular, where FET will be found in the Horizon Europe, we need your support. It's very clear here that our ambition is to position now FET as part of what we call pathfinding activities with the European Innovation Council. So it's not only the ERC, but all this bottom-up research, where many of you have been excelling for years and years, and quantum is one of our best, stories that we have been selling for years now. You need, therefore, somehow to talk to your member states, to talk to your parliamentarians, and make sure that this pathfinding that I'm trying to position the whole FET story in there continues. This is absolutely fundamental. Yes, to have innovation in Europe, and we need more of that. I think you are the first to acknowledge that. But yes, also to have FET. And FET has two dimensions, the disruptive and long-term research dimension, and the breakthrough dimension that you heard also yesterday. We need both, and really I make a plea for all of you to be able to defend that approach, because we need to continue this kinds of FET approach all over Europe. It's one of key ingredients of success so far, and we see no reason why that should be stopping. And we see also no reason why FET open projects that come in the quantum area will not be part of the flagship. At least this is our ambition today and hopefully tomorrow.
So it's good to finish by this message from DG Research. Thank you very much, and thank you for your contribution. So I think it's lunchtime, as far as I know. Sorry.